So hi again, this is Sammy. I'm going to continue doing logs, but I thought this time I'll just remind you of the log rules. So I wrote them here in blue. So if you look at the log rules right here, the first rule is the most important one, which is this one right here. Log base a x equals b. What that means, it means a raised to the power of b equals x. And that's why x equals a raised to the power of b. This is what logs are all about. So if you know this, then if I give you any question that says log base 2 3, log base 2 8, what does it equal? Then you know 2 raised to the power of 3 equals 8. So the answer is 3 and so on. Okay, and then the power rule. So if you have an exponent with the log right here, like x to the exponent of n, then you're allowed to bring the n in front of the log, and then you'll be able to solve for n if n is what you're looking for. Since now it's not an exponent, it just came down. Now also log xy, so if you have two things that are multiplied and you log in them, you could change it to log x plus log y. And also if you log in two things that are divided, you could change it to log x minus log y. And these two things here, you could change them from going this way or also this way. Sometimes you have to combine the logs and make them into one log, and sometimes you have to expand the log and make them into two logs. Every question is different. So depending on what the question is asking, you will be able either to expand or combine to be able to solve the question. And then the last law is basically log base ax. It's called change of base. So if you have log base ax, you could change it to log x equals, you could change it to log x over log a. And the reason you do that, because a here not being 10, because when you don't write the base in here and here and here, that means the base is 10, and that's programmed in your calculator. The log that you see on your calculator is log base 10. So if I give you log and the base is not 10, you could change it to log base 10 this way. So then it becomes, instead of the base being a, now it just becomes 10, and then you could solve it using the calculator. And I'll give you an example. You know, here if I give you log base 3, 27, then you know you're asking yourself 3 raised to the power of what equals 27, then the answer is 3, because 3 to the power of 3 is 27. Okay, but if I change this to 2, so if I go log base 2 27, then 2 raised to the power of what equals 27, we don't know. This is going to be a decimal answer. So here you could change it to log 27 over log 2 and plug that into your calculator. It'll give you that decimal number that when you take 2 and raise it to the power of that answer, it will give you 27. So that's why we do change of base. Okay, now let's go to the question that I asked up there, and to solve for x or evaluate. Here with this question right here, what you want to do is log base 2 8 here right away, you know that's 3, because what it's asking you is asking you 2 raised to the power of what is 8. So that's obviously 3. So let me just write that down here. Plus log base 3 1/3. Maybe I'll just manipulate this a little bit. So I'll change that to log base 3 3 to the negative 1 equals log base 4x. Now, when you have log base 3 and you log in 3 with the power here, you could bring the negative 1 to the front here, and then you'll have negative 1 log base 3 3, and log base 3 3 is 1, and so the answer will be negative 1. Or whenever the base is the same as what you log in, you could cancel these, and then you're left with negative 1. So basically this becomes 3 plus negative 1, which is minus 1, equals log base 4x. 2 equals log base 4 x. Now x would be 4 raised to the power of 2 would equal x. So x would equal 4 squared, which equals 16. Okay, so that's for this question. Then let's take another question. So here's a question: solve algebraically 2 log base 4x minus log base 4x plus 1 equals 1. So here in this situation here, we're gonna go from the expanded form to the combined form. Since it's a minus right here, then it's going to be division. But before we do that, though, we got to bring the 2 up, because you cannot do the this rule till you bring the 2 on top here. You cannot have anything in front of the log to be able to apply this rule. So the first thing, we're going to use this rule right here and make this here into log base 4 x squared minus log base 4 x plus 3 equals 1. Now we could apply this rule. So when we have minusing, we could change it to dividing. So it'll be log base 4 brackets x squared over x plus 3. God, that's a square there. Let's make it a little bit more obvious. Equals 1. Now we go back to this most important law right here. So even though here it's x, but here it's a big thing right here, but still the same rule applies. So 4 raised to the power of 1 should equal this. So basically x squared over x plus 3 equals 4 to the power of 1. Now that's just 4. I'm going to cross multiply that into here. So we have x squared equals 4 brackets x plus 3. Now I'm just going to move this a little bit this way. So we have x squared equals 4x plus 12. And then move everything to one side, equate it to 0. So x squared minus 4x minus 12 equals 0. Now we factor this and we're going to get x minus 6, x plus 2 equals 0, because what multiplies to give me negative 12 and add to give me negative 4. This is the combination. So therefore, x equals 6 and negative 2. Okay. Now in logs, when you get your final answer right here, you still have to take the numbers and plug them back into the original equation to see if this is going to be positive or negative. Because if this is negative, then you cannot, or this, then you cannot log a negative number. So the 6 here works, but the negative 2, you see here, it will give you negative 2. You cannot log that negative number, and therefore negative 2 has to be rejected because you cannot log negatives. Always test in the original question. You cannot test here. You cannot say, oh, it's negative 2 when you square it, it's going to become positive 4. No, you cannot test in here. You have to test always in the original question. Okay, so we'll go to the next question. So here's a question. They said simplify, and they want you to simplify this question right here. So basically simplify this. I think the first thing I'm going to do here is bring the x down. So it'll be x log base 2 4, which is log base 2 4 is what is asking you. It's here. It's asking you 2 raised to the power of what equals 4. And you know, 2 raised to the power of 2 will give you 4. So this will just be x times 2, because the x here and the log being here, it's a multiplication relationship. And log base 2 4, as I said, that equals 2, because 2 raised to the power of 2 equals 4, and that's how we got that too. And now this will be simplified to 2x. Okay. Let's do one more question and we'll end it there. So here they want us to write this as a single logarithm. So basically we have to combine these logs right here. But the issue here, we have a 3 and this doesn't have a log in it. So how are we going to combine these? So the first thing, we got to get rid of that dilemma, which is the 3. And to get rid of that dilemma, which is the 3, now let's just take the 3 right here. I'm just going to write it on top here. Okay. And we want to express the 3 as a log base 2, because we want this expressed in log base 2, because the bases here are 2. Now, remember this rule right here. It says a raised to what power equals x, okay? Or a raised to the power of b equals x. So here, the same thing, 2 raised to the power of 3 should give us the number that goes here. So 2 raised to the power of 3 is 8. So 3 could be expressed as log base 2 8, and that's the first thing you want to do, to change the 3 to log base 2 8. Plus, you have to bring that half to the top, okay, to be able to combine. So log base 2 x to the power of 1/2 minus, you bring the 3 up, and that would become log base 2 y cubed. Now you could combine, and when you're combining, anything that has a positive in here in front of it goes on top, and anything that has a negative goes on the bottom. You know, like multiplying, dividing, but a lot of, and I'll show you one that to make that clear. It's easier to combine logs by just thinking whatever is positive, I'm gonna put it on top. So the 8 and the x to the power of 1/2 is just the same as the square root of x. That's x to the power of 1/2, just the same as the square root of x, goes to the top. And then the y cubed will go into the bottom, okay, because it's minusing. And it's obvious because if you're subtracting, you divide, and if you're adding, you multiply. But a lot of students get confused with if they have something like this, and I'm just going to give you an example right here. So basically, if we have log base 3 7 minus log 3 14 minus log base 3 18 plus log base 3 6, lots of students, when they want to do this, they get kind of confused. They go, okay, log base 3 7, and then I'm dividing, so I put this 14 underneath, and then I'm dividing again. I put the, where do I put the 18? Do I put it under the 14? To get rid of all that confusion is basically what you do. You look at this and you say, anything that has a positive in the front, which is this one and this one, I'm going to put these numbers on top, and anything that has a negative, which is this one and this one, I'm going to put those numbers on the bottom. So basically you go 7 times 6 because they're positives, and then the 14 and the 18, they go on the bottom. So the 14 and the 18, they go on the bottom, and of course they're multiplied. All right, and now it's best to reduce. So log base 3, the 7 goes into itself once, it goes into 14 twice, 6 goes into itself once, it goes into 18 3 times. So we have log base 3 1 over 2 times 3 here is 6. So just that's what it becomes, and that's as far as I will take it. You cannot simplify this unless you do change of base. But I'm just trying to make a point that if you have lots of negatives inside and you don't know where everything goes, then anything that has a positive goes on top, those numbers here. Anything that has a negative goes on the bottom. That's how you do this. Okay. As always, thanks for watching. Till next time. Bye-bye.